become much art, not just one.
Well,
art.
okay, if you're going to have more than... I'm not trying to talk about the whole big picture with all the students. This would just be specifying a specific one artist here. That one artist
It could be
does a single piece of art.
So that would be one artwork coming out of that process, and then
well,
two
there could be
physicists
many. He's
would-
just showing an example of what I understand. There's a branching ratio.
Yeah.
And then two physicists would respond to
Two
an
physicists would
artwork.
respond to that.
So that's the interesting part here. What forms do they have to respond to an artwork?
There's plenty of different forms, but if you want...
All kinds of physics input, and this is one of the pieces of art that comes out of it.
Yeah.
And then a couple of physicists look at it.
I mean, what exactly comes out could be left up to the individuals to determine.
Sure.
Or you could set it ahead of time. But you could try to force it to map onto a physics process as much as possible. So like the particles at the end here, the way that you actually see them in real life is because of this weird cascading effect. So that could be a single piece of art, which then becomes a cascade of pieces of art. So maybe you're making prints. So something that you can produce many of, and it branches outwards in a very similar way. And then...
One of the ways a scientist could take this is turn this into math, right?
Like turn the artwork into math?
Yeah.
Why would you want to do that?
To calculate
Just for fun.
the transition probability.
The transition probability.
Yeah. How often? So, for example, you have this is a proton, right? Or nucleons. There's two nucleons. Two of the quarks hit. That's a gluon, I'm assuming. You get two top quarks. Whatever, and then you say, when these two quarks hit, this isn't the only thing that can happen. All kinds of other stuff can happen. This is one of the many, many, many things that can happen. How often does this happen compared to the other? So you can turn it into math to calculate. How often does this happen compared to the other stuff? That's one thing. Another thing you can do is take this information and say, okay, if I want to try to determine this, there's one way you can do it mathematically. You can calculate, given a theory, and what you expect all of the strengths and what all of these vertices to mean, you can calculate it mathematically what the outcome should be. The other thing you can take from it is, okay, if I were to design an experiment to try to detect this experimentally, to see if this actually happens experimentally, this can give you some insight, because then, like he said, these are these cascades of particles. It's just, this means it's a whole crap load of stuff, and you can't really distinguish these. So I need an apparatus that is able to distinguish whole boatloads of particles that you cannot distinguish and measure their energy and their direction and distinguish this bunch from this bunch. Okay? Then I'm also, I need an experiment that is able to detect this thing, which is a lepton, which could be an electron. Okay?
In this case, a painting or something.
Whatever. I mean, one of the things I could take from this is how am I going to detect this? And I know this is a B particle, which decays very quickly after it's, so what do I need to do to try to detect this? So you could use this as a basis for designing an experiment.
Yeah.
But
You could also color it pretty colors and hang it on the wall.
There's other things you can get out for just more information to provide people later. So I mean, this piece of art here, it's going to have some properties to it, right? Whatever color, size, and all that stuff. A physicist can take those properties and kind of treat them as physics properties and say, okay, well, it's 10 meters big. You're going to call this a very heavy particle. And so that will determine what the properties are of the physics that's coming out of it at the next stage.
Yeah,
So you can read properties from the art to turn them into physics properties for whatever they do with it later.
That's true.
So if this is really heavy because it's a big art piece, they can make these things have certain properties as a result.
so that would mean that then that suggestion would then be taken up by the artists, who would say,
Well, so this step here is physicists doing stuff. So they then calculate, say, how much momentum these particles would have because this was really heavy, for example.
Yeah.
And so then they've got new information out of it, which they then pass on to the next piece of art. So it has to be, the next piece of art has to be the result of something that had a lot of momentum, a lot of energy in a certain direction, maybe.
Yeah.
So you would treat artworks as particles.
Could
Yeah.
do
Yeah.
that. That's one way of doing it.
I like the idea too that these, in the diagrams that you have, that these moments, I know that they mean something, the squiggles mean something more than I understand, but that could represent a process like an artist and a physicist in dialogue. And so it's almost like a legend.
Yeah,
They could be
for a physicist, this whole diagram, everything that's important is these
Those
intersections.
yeah,
These
sure.
define who is interacting with who, which is a
But
big
even
part
these,
of this.
but these lines,
Yeah.
so therefore these lines are what are the
Those are
product?
identifications. Those are products that are
That's
coming
communication.
out.
Oh,
So
that's
this is a
interesting.
communication between
Yeah,
this
yeah.
point and this point. So this is a communication. In physics, we have a W boson. Okay, and a W boson, when it breaks up in this way. Actually, it can break up in a number of ways, but that's one of the main ones. So these are lines of communication.
Yeah,
Okay.
I was just thinking that if there's, for instance, if this is a single physicist communicating to one artist, then potentially then there's other ways that the diagram could then be visualized as, like, if it's a zigzag line, like this means an artist and physicist together. This means a physicist alone. This means an artist alone. You know, like-
We've got a lot of.
do that.
We got all
Yeah, so these often when we've got three lines here, that actually corresponds to three things coming together, three
Yeah.
particles. So this could be three physicists meeting three physicists.
Yeah,
So
and then-
six physicists producing
One
or
artwork.
giving you one piece of art.
Yeah.
So that's your initial big talk, which lasts half a day or whatever it is.
Now, you gotta be careful here, because in physics speaks, these are very programmatic. They mean certain things.
Exactly.
Certain things are possible, other things are not possible.
Right.
So when you're moving into art, where there's more possible than there is impossible. In fact, there's nothing
Nicely
impossible.
put, nicely put.
Yeah, there's, in physics, there's more impossible than there is possible. Because we have conservation laws and things. There's things, in art, there's nothing that's impossible. In terms of
Yeah.
conceptually,
Yeah.
right? So one has to be careful here. You don't want to stretch the analogy too much.
But it's
Right.
interesting to think about if we're designing a model for this transformation process, that if we're
Yeah.
basing it off of one of these and not, we could use it literally in terms of treating this as a heavy particle or these, like you're describing, or it could just be a diagram from which we
Yeah.
put our new metaphors onto.
I mean, it seems it's fine to have metaphors, but really we want to just encourage the production of good art.
Yeah.
Right, so we just have to have some variety of processes
Yes.
that will just fall on fertile ground and produce good art. So then we can subsequently decide to draw a diagram, but I don't know how, in a way, setting this up in advance is going to produce good art. It might,
Well,
you know,
you can.
like want
You don't have to have the whole thing necessarily set up in
Yeah.
advance, but you can have a general plan. You can set up the first bit
Yeah,
and then
maybe.
let it flow and map it later. But it can provide some inspiration too. I mean, this
Yeah,
bit
I
here, you could say this piece of art would ideally be something related to electricity, because it's a lepton. You can.
Yeah, that's
that can,
beautiful.
it can focus some of the art.
request that type of art.
Well, I mean, it depends on the artist.
Can I offer another one? Can I offer a slightly different one, somewhat different one?
Is if you look at, the scientific enterprise, there's a whole bunch of
Yeah.
parts, and then, these are curtains. And then you raise the curtain and you look at it and you say, in this part, what does it look like in terms of, the question that you're trying to answer? And what does it look like from this angle, which is the techniques being used? And what does it look like when you're looking at it from here, meaning the outputs? So you're looking at something that's very complicated, but you're looking at it, we show it to you in different ways. So when I show you ultra cold neutrons, okay? Big question, electric dipole moment, does it exist? If it does, that means our understanding of our theory is wrong. We want to find out if it's true or not. That's the big question. What are our outputs? Well, we're trying to, measure to see if we see a signal, this particular electric signal, blah, blah, blah. What are our techniques? Well, what we're trying to do is get these neutrons, create them, slow them down,
because we can only create them when they're moving fast. Slow them down, until they're practically stopped. Then, you know, what are the outputs is data. The interpretation is, yeah, so once you've got the data, what does it mean?
But like as far as the art project goes, would you say that, you know, you want a bunch of people to give representations of the question?
Yeah,
You're asking
that's
some
what I'm
people to-
saying. So when you
to give
raise this,
Yeah.
here's an enterprise, choose an enterprise like what was the one in Ron?
Something, yeah, and then.
And then show, and then have people give presentations about all of these different aspects.
Yeah.
So this
and
is
then-
the big
but then-
question.
But then.
These are the techniques. This
The
is,
artists latch on to one.
Whatever they
Some
like.
guy takes pictures of equipment, some guy tries to make the
yeah, so you
abstract,
want to show it from all of the different angles and see what inspires somebody. If somebody says, oh, I like that.
So this is rather a star than, I mean, you have it nicely drawn as
Well, yeah.
three-dimensional, but.
Oh, no, yeah, it's
Yeah,
it's a
I think-
hyper-dimensional,
I
it's a
think-
hyper-dimensional,
I think
you
what you
know.
need to do, like, we've understood this big picture, now you need to, I think part of this discussion here is to find a way of mapping out how that would work on a calendar. What
Not
would happen
necessarily. I mean, that's-
when-ish? I mean, does it have only just
Yeah, that's right.
a
Well,
start
yeah, yeah.
and one artist?
And one physicist and they meet like every 2 weeks. Like, I guess that's something that could also happen. Or is it,
Right now, anything's possible. We want to hear what people are interested in investing in, and then we'll design the experiment based on it.
I mean, even so, maybe this is probably less exciting for you, but I mean, so far the creation side has been on the artist. But I mean, as a scientist, we give talks or this and that, or make slides. I mean, it could even be useful, just it's sort of prosaic, but to have interactions or feedback from artists on, let's say, slides for a talk we're giving, ideas for a talk we're giving, which I realize is probably not so interesting to you, but it could be beneficial to us.
So ways of the slide as a form of communication,
Yeah, so like help us communicate better.
right?
But I mean, it's certainly the visual and also.
Well, I think if it was on, let's say, the original science seminar in January, and if what your slides reflected back on that topic, I think that would work. But if your topic is not related to the original science seminar, then it's going to go too wide.
Yeah.
But I
But
don't
it
see
could be a
why.
critique of that presentation and
Visual presentation, that would be useful. Visual
from a different perspective.
Right.
That's an interesting point to actually have a seminar where you could have a component where the receivers of that artists would say, well, that is not as useful to me, and that kind of information works better for me. I understand, and we can paraphrase back, so you get a sense of how something.
And maybe repeat a seminar, maybe to a different set of artists, but
Do it again.
maybe even the ones on the second one, once they've done their art, you
Right.
could actually expose them to an evolved version of the presentation.
Yeah, right. Well, we can have one group, I don't know what you meant by
Deplorables, irredeemable.
we can have one group where they're just giving feedback on the original science seminar.
And then they actually can feel, so, I mean, get a
And
feeling
making
for
artwork, and
what
the
they
others
did,
making
has
artwork,
anything
they're not giving
resonates at
feedback.
all with what.
Right?
Yeah.
So what did you mean when you, I mean, I know the control group, but what did you mean in terms of what you were proposing in the original? What would a control group look like in this context?
Well, I was just, I think I was just using that as an
yeah.
example.
Well, I think I brought that up initially. We were discussing, I think, with the diagram that you made, you know, that we might have these different streams, you know, and you would have one, the control group might be exactly the same as what you've already done before in raw data, you know, and you just take that exact same methodology. You could say, did our results, now we have a different physics topic, but did we get, can we draw the same conclusions that raw data did? But now we've tweaked it in specific other ways. So now we've introduced feedback from scientists in group 2. We've maybe done a many-to-one relationship instead of a one-to-one relationship in another stream. And then the idea was, you know, after taking these multiple streams out, you come to some kind of conclusion about what worked, what didn't work, what did we enjoy. And then I think we had gone on with like a natural evolution of the artists would choose what stream they want to choose in the next one, and then you can kind of watch as you iterate the process and you see the evolution where do artists tend to gravitate? Which way do they work? You know, what do the scientists get out of it? What do the artists get out of it? They might get something different. Like I think we were talking about what is success, and I was thinking, well, to me a direct translation might be success, but to an artist that wouldn't be translation. They wouldn't have succeeded if they only gave exactly back the information that they were given. They want to create something more and evoke emotion. But so, you know, you have different levels of success. I don't know. I think that's kind of.
I mean, I guess my extreme. We were talking specifically about here's a process with artists and physicists. Here's a different process with artists and physicists. Here's a different process to run them in parallel, and then get everybody back together and see what worked and what didn't. Then iterate and sort of. You're essentially doing an experiment on different collaboration models.
That's what we envisioned.
The question, that's another,
Yeah, sure.
we move back into the question of what success, what exactly are we measuring there? We're measuring whether, is it a yes, no sort of, that the feedback at this point produces a more accurate kind of interpretation, or how do you measure the accuracy? Like,
That sort of, you would have to test it back to the scientists and say, do they see the original theme in some way
and
affected or
then what's the value of that to their perspective?
is that actually the intent?
Yeah.
But it would give you data in the sense of if you're doing an experiment on.
That's sort of a natural way for us.
Okay.
Or yeah, another way of doing a control would be, you know, holding something else constant. Like the very first level are all artists of the same medium, and then the next one is all the same medium, or something. You know, you could picture levels like that. You know, that could. However, you know, if the time frame is short enough, like only 1 week, then it could be something. You know.
Well, I had in mind, don't talk to the scientists.
I still sort of think, I don't know, I would love to see how a scientist and an artist describe their creative process.
Yeah.
And
Through language?
it's the only way I would know how to.
Well, we can
Get
have
to
a
that.
component of that in the project. It might not be
I would
within the
just, I mean,
experiment.
I think that, I would guess it's, I assume it would be fascinating to see the similarities actually.
We don't see their beauty that they see in their math logic and how they go off with those thoughts.
I'm not saying you don't, because there's, you look at a tree is basically mathematics. Like this is
Right.
why I can do this. That's all math. That's beautiful in its own way. But the fact that they got those equations, so I agree.
Well, I mean, not,
I'm saying I
not
can
like
see.
not in every case, but percentage of cases. Just like the beauty part, I'm sure there's some scientists who kind of are more open-minded.
No, like yeah, no, for sure. I'm not saying that they don't see that.
Yeah, and the same with,
I'm not saying
same with artists. Some artists do see that.
What I'm saying is that like that aspect, just plain old beauty, gets shoved out of the period. I'm not saying that other people don't see it. I'm just saying like we forget about it here. We get lost talking
But
about all these things.
I also think, like you think that is necessary to point out to them, I think also.
No, I mean necessary for even us. I'm talking about like everybody. I'm not. I don't even just mean them because, like we say, because even you say they see the beauty in their mathematics.
Yeah.
They see it.
Yeah, there's just something uncomfortable about beauty, even like in the context of art. You cannot just make something beautiful. Kind of a twist to it or something.
You can make something beautiful.
Yeah, but I mean, of course you can, but somehow when you present it as a critique in art, class, there has to be something else there.
There doesn't always have to be something there. So there's
I
a
know.
thing like everybody's saying like you have to have this
Yeah,
twist.
that's
We have to have the
something
touch.
that I realize, but in the class I feel that there is a kind of a discomfort, not just maybe from me, but from the teacher.
Call them out on it.
Yeah,
Yeah, I'm saying call them out on it.
it doesn't matter, just like that it is an existent problem even.
A discomfort with what?
Well, like, you know, if you just present something that's beautiful, like, it doesn't just fly. Like that, it has to have something else in it to count as a...
So in art, we think of beauty in terms of aesthetics, and yet in science, we would think of beauty in
Yeah, like this kind of critical...
It's like how, like what was that quote about the most beautiful equation is the one that solves the most problems? And it's just like it's one of those like kind of oh my god, he did all this kind of thing. Like it's something that works.
Yeah, it kind of justifies it.
Yeah.
Well, isn't it said the most, also the most beautiful artwork is the one that gives the most meaning? Kind of similar.
Yeah, it's definitely a similar parallel.
Yeah, and touches on a lot of topics at the same time, right? Same as an equation, just on one.
It's an interesting way of thinking of beauty. It's not how I typically think of beauty, but if you've been struggling with something and then suddenly you get this, it is like if you're making something that suddenly when it's done or you know it's right. You know that sense of like,
Just like they have their equations, we have our principles of
Exactly.
design, and our principles of design that we learn in the lower levels of school help us to eventually develop this, just like their knowledge in math helps them develop those equations and theories that they come up with. And so there are a lot of parallels of how we finally get to that beauty. It's pretty complicated.
but it's simple too.
Like a verisimilitude that is true for that the world in which that artwork exists, then you can kind of follow the steps of that logic within that framework.
I think it would be really interesting even to see, like, say I draw something, say I draw a box, to have somebody explain that to me in math, or either the drawing or the drawing on the paper or whatever form that takes, or beyond that, looking at a fantastical situation and trying to explain that.
Remember Saul LeWitt's drawings, which would have these instructions that say, draw a line, and draw another line this long, and make, follow all these sets of rules, and the result will be a piece of artwork. Those things can, I've never tried, so I can't say for certain, but I would imagine that can be broken down into like a very reasonable set of logics that could probably be expressed mathematically. Does anybody nod their head, shake their head?
Like his one specifically, or do you mean the concept in general can be translated?
Yeah, well, that way that conceptual art work, where there are a set of rules, and that set of rules creates a framework for art to exist. It doesn't have to exist, or the steps can be followed, and you will wind up with the Saul LeWitt drawing. And that artwork is made by the rules.
So the artwork in that case would be the process of following the rules and interpreting them.
Yeah, or well, it could be that. It could be the equation. Like, are you familiar with Saul LeWitt? Are you familiar with Saul LeWitt?
Yeah.
Anybody? You are? He was one of the founders of conceptual art, and he would make these lists and say, do the things on this list, draw a line in this direction, and then from the end of that line, draw a line in this direction, and so on. And then the result was the artwork. So he wouldn't actually make the artwork, he would just make the list, and then that would be the artwork. Then a museum could do that and draw his piece on the wall, or whatever. And it was a clear step to delineate, a clear set of steps that are delineated, and then you do that, and what results is the artwork.
It's a bit of a challenge, and one thing that at least strikes me is that it feels very asymmetric between artists and physicists, in that it feels like a physicist comes in as sort of like Oracle, Delphi, and pronounce, here's a theory. We're working on one thing, you're working on another thing. Which I think it's much more accurate than having us on some sort of pedestal. It would be nice to have a bit more parallel, more back and forth.
Well, this feedback we were talking about before can happen at every one of these steps. So this way is in fractals, it's rule-based. You go from here to here, you step forward, and you can end up in places you could not possibly predict from where you started from. That's one way to do it. right? Then another approach would be, you can seed a discussion, like along the lines of what we were talking about, looking at all of the various dimensions of a scientific project or enterprise, and then people can gain inspiration from all of these different levels. And then you could say,
You could have channels, you could say.
you
who-
can
who- who
channel
wants
them,
to-
or you
yeah.
could say everyone, you know what, we're gonna cross these two. We're gonna cross the streams. Think a Ghostbusters.
Across the stream.
A Ghostbusters analogy. We're gonna let these go, and then you know what, down here, we're gonna cross the streams. And let's see what happens, like a Ghostbusters. So you could do it that way. Let's take 5 blank N iterations, and let's cross the streams.
But actually, so speaking of these streams, I mean, something like this came up in our discussion, and I sort of have a drawing over there with, you see it. So the idea would be you have 3 different, or some number of different methods. So here's method 1, let's say we do method 1, method 2, method 3, and you go off and let things happen, and then at the end, everybody comes back together, and you see what works, what didn't. So the hard question there is how do you judge what worked and what didn't? But a self-consistent thing you could do is let people choose which of the streams they want to go to on a second stage. So you have 3 streams here, everybody comes back, you see what came out of it, and then people choose what they do for the next one.
Do you have examples of what you mean by streams? I mean, we were thinking of, the experiment, the theory, the analysis.
These are the streams
Yeah,
here.
but, is that what you're thinking? Like one guy would do some artistic treatment of the data, and someone does an artistic treatment of the equipment. I don't know. I'm just trying to picture what I really mean by a stream. Maybe we don't have anything, but...
I mean, I guess the thing that comes to mind is just different ways for the interaction to happen. So, I mean, you could have 2 artist nodes, like a piece of art goes to another artist, or you have an artist, physicist, or even just some completely different approach.
There was actually this question of the physicist response if they're within a chain of reaction or whatever that will be, it doesn't have to be a chain, but like just on one of those lines here. And you said, well, a physicist could create a calculation or an equation or a diagram or like those prints, and you say that that's not an issue for a physicist to do that, right? Because we had quite some objections about that. How do I?
So it requires some minimum pre-understanding of what's going to be included. You can't just leave it of all the physics, but it's also somewhat depends on the creativity of the scientist.
Yeah, I mean, that's where that's
I mean,
a lot of creativity.
again, I'm being really linear thinker, but another possible different streams are just different experiments or something. There could be the Atlas stream, because it's different kinds of data, different kinds of equipment, different theories, different looking data.
The more I think about this, the more I see these streams to be, is the nature of the interaction. Okay? So what's the nature? This could be, for example, a rules-based interaction. You're at some point, the thing is seeded somehow, the ideas spring forth, and then along this stream, there are rules-based interactions. When you get such and such an output or input, there are only certain outputs allowed. And then those get handed on, and then you get that, and only certain outputs allowed. It's like Feynman diagrams. It's rules-based. You can end up with crazy figures, but at each step it's rules-based, and the complexity comes from the iteration. You can imagine another stream where you take the inspiration that comes from the initial seeding and say, okay, for this stream we're going to do something slightly different. We're not going to have whole rules-based, but we're going to have a different structure. There has to be some kind of a structure that tells me that this stream is different than this stream, or else it's all a mishmash. What do you mean by stream? There's got to be something different about this compared to this. So what's different about this? Maybe the difference about this one is that we're only going to deal, like he said, with data, visualization of data.
It could be part of these streams too. You could just see, okay, these guys are gonna say what they can do only using red or blue, or so, I'm just
Whatever,
making this up.
you know, but what the point is that these things need to differ in some respect. The form of the interaction has to be different, and you're free to choose what it is, but they need to be different. You can't say, oh, you do whatever you want here, you do whatever you want here, then you don't have 3 streams, right?
I mean, so I picture the stream should also be, in some sense, so I picture the stream should differ in the way scientists and artists interact, rather than specific
Sure,
topics.
that could be too.
Absolutely,
I mean,
nature of the interaction, what is it?
like one scientist starts it off and never sees it again, right? Another one, he starts it off and then you come and you look at it later and it reminds you of something and you apply some more input.
Or you're gonna, like a scientist and artist working in parallel somehow. That could be one stream. Another stream would be
Yeah, because
kind of
I could ask for more data.
like the node approach that you've done already. Like a third one would be maybe you're only allowed to communicate by postcards.
Yeah, right, okay,
I mean, it's a bit silly, but
no, you're right,
but I mean,
exactly. That's what I'm
there's
thinking.
different interaction
Just some
methods.
They have to be different.
Constraint that'll spawn something.
Something
Yeah,
different.
yeah,
You need some kind of a structure that dictates the level of the interaction. How do the people communicate with each other? What is the nature of the interaction between protagonists and what's being transmitted? Is it strictly rules-based? Is it based on some other criteria? Like he says, they work in parallel, they cross every once in a while, or they cross all the time, but only certain kinds of information are allowed to be passed, right?
Yeah.
But that's your problem. You
Yeah,
tell
I
it,
would-
you know, what's
yeah.
what's interesting to you, these kinds of, we could help you of what kinds of things that we can do, right? But you guys, what's interesting for me as the artist?
Well, I was just going to say for the differences between the streams, I think it would be interesting for myself to see, you know, if one was completely void of any interaction, so sort of redoing raw data, so then see what evolves
That would be
with
yeah,
nothing.
I know, I
And
like
then
that.
having
Yeah, yeah,
maybe
yeah.
minimal
See how it
interaction, like
compares.
only interaction
Yeah.
when the art is being passed to artists. There's also a physicist there, could be another, so then you have interaction, just
yeah.
only feedback, and then the third one would be continual. Do you get any benefit from the artist during the creative process, being able to ask questions and bring that into their art?
I think
Like
for
those
one thing,
three-
you'd get different art, right? You'd
Right,
get different,
well,
you
but
know,
then,
and that would be worth
you know, that would
learning,
be our
wouldn't it? I
theory,
know.
would be that, you know,
Yeah.
would be when a scientist looks at it, at least would be my hypothesis, is that in that third stream, I think that I'd be able to see more physics. I'd be able to say, oh yeah, this is a lot closer to my understanding of the concept, and then maybe the first one, it might be more abstract or emotional or some other interpretation.
I mean, another
Because-
obvious stream is just the type of art, like this is just going to be the watercolor stream,
Yeah.
or this is the rap musical stream, or, you know.
Yeah, so
Well,
that's
that's more a individual channel
Is it?
within a
Yeah.
stream, probably,
Yeah.
because you can have multiple artists in a stream. They can be working
Oh,
in
yeah.
parallel.
Oh, I see.
It's the
Yeah,
nature of the interactions, but that's
Yeah.
key, like David said. You gotta specify what that is.
Coming to that interaction, like, so what I'm very interested in and also maybe a little bit worried about is that picking up on the conversation, we always talk about the physicists and the artists, but we are specific people coming with a specific background to this, and I would be very interested in looking through that a bit more, because we're always on this, when you mention like, when is it a mishmash? Of course we can set up the rules, but then it's still, we're not looking through like, where are we actually coming from? If you work with one artist, it will be completely different than working with another artist.
Sure.
Or working with a different physicist, it will be different because just of the interactions we have.
Dynamics.
And it feels very constructed to me, but we have to work somehow, you know? I understand that, but it's still like, we're completely different, even though we are artists.
Sorry, I just want to mention this one idea because I'm so like hung up on this still because I find it fascinating. Is that in the raw data project there was like sound, image, audio, text as sort of these elements of artistic production potentially. And then I love this idea that this could be these elements, these particles, could then be translated as mediums, or what you were saying, like that, like that the properties of that particle could then be placed on a sound artist has to work with those properties within their artwork. And that's part of the rule-based
Yeah.
game that's happening.
Yeah,
Yeah.
absolutely. I
Certainly
mean, that's,
fun.
I think that would be really super interesting. You know,
Ben, yeah, sorry that I.
Oh, yeah, no, it's actually, well, two things. So the first is doing these different streams. I mean, it's a lot like what we do as a scientific experiment. You
Yeah,
measure different things,
yeah.
and this feeds into your research on, let's say, artistic process and communication. The second thing, Diana said, one of the challenges, though, is that because you have different individuals working and they do different things and different topics with different physicists, there'll be a lot of individual fluctuation. And this is actually something we deal with in experiments, where we get, there's a lot of randomness, and generally you have to take a whole lot of data, because when you take out more data and you average in a sense, it gets rid of the randomness. So I mean, ideally in each stream you have lots of artists working in each stream. And
Does the person actually change in the experiment, as an observer, depending on the personality, for example? Could that be?
Well, I could behave in different ways.
I mean, there's a certain degree of, he's absolutely right about the randomness. If you do it enough, you average it out and it's not random anymore. It's like you're looking at the surface of the ocean from way up high and you're looking at lots of water, it looks flat. But when you look at up close in any one little spot, it's likely to splash up or dip down. And the interest in the complexity comes from the individual, the individual randomness. But when you average out the whole thing, it becomes, you get base behavior, which is, to me, less interesting. I think the interest comes from the individual fluctuations. So you could have, you could imagine two identical streams, two identical sets of interactions and rules, but with different groups of people. And see if you end up in a different place. Or how different the place
so
is.
within one
Of course
stream,
you would, but it would be interesting to see.
Within one stream, to try and see how things can compare with big picture versus small picture, you can have four artists, whatever it is, all working in parallel based on one topic, but they only ever communicate with one physicist, so they're always going back to the same physics thing, same source. They're always there, perhaps, and then when they deviate with the next bit apart, you see how they've again gone different ways based on that one.
You could do that. I mean, there's different ways to split up this pie. It's just, there's, how do you gonna, there's we could sit here all day and
I know,
come
but
up
is
with new
it
ideas.
multiple physics streams, for example, that makes a difference, right?
Yeah.
So.
So what we have to decide is what kind of interactions can take place, right? So there's, like David said, I think postcards is a great way to do it. Because it's a joke among physicists, you don't really understand it unless you can, explain it on the back of a postcard. Oh yeah, if you can't, if it takes you 3 pages, you don't really get it. So you could say that. That's perfectly valid.
Well, I was just making this as an extreme example of a restricted interaction.
But it's perfectly valid. Or you could say we only communicate by email, which means a printed word.
We have this with elevator pitch, where you just told us that you have this great idea for a movie, and then you basically have the chance. You enter an elevator, and you have a producer there, and you just have like those few seconds to tell the main essential things, right?
So let's define, one of the things we could do is define all of the potential interactions. There's, phone calls, written, video, it could be video clips, Skype. How do we interact? Could be presentations.
We could even put people in an elevator. They get to meet once a month for a 10-story elevator, right?
That's right. But you could do it as much as you want, but let's think creatively. These are the interactions, right? And then so that in a sense says, what are these lines like? What is the interaction? How does information get passed from one place to another?
And that has an influence, of course.
And then that's one of the things. And then the other things is then how do you iterate these? This is a rules-based approach. When I end up here, there's only a countably finite set of outcomes based on this interaction. Whereas this one might be different. It might be, more, you might say, like he was saying, we go just the artists and then the physicist comes at the end, see what happens, or the physicist happens all in between. But, define the sets of interactions that can take place. And then think about creative ways that we can then combine them with the information being passed.
Right.
In ways that you think might yield interesting complexity. Because I think it's the complexity
the diversity of potential outcomes, which makes this project really interesting. Because if everybody ends up in the same place, how boring would that be, right? So you really want to make it so you optimize the entropy. You increase the number of potential outcomes
Sort of
to the largest possible
build
number.
something in that sort of forces diversity.
It forces things to be
Then you're a
diverse.
good chance of, especially in this type of thing, you have then a better chance of really coming up with something neat that you might not have realized.
But you have to be careful, right? Because you can think of some ways that bring everybody to the same place.
Yeah. Well, that's
So
why
if
you
you
want
don't
different
construct it
streams.
carefully,
right?
you gotta think, how can we do this?
Yeah.
Knowing the finite set of interactions, the finite, bits of information that can be transferred.
But it was interesting that I never learned math that way. We learned it more by memorization and just memorized all these things. Whereas he had a visual aspect added to his.
So he knows how it works.
Right, and so he learned the patterns that came of numbers and to see those patterns in objects and places. So it was a way of combining and overlapping the disciplines, I guess, instead of keeping them so separate.
Right, yeah.